India's Decade. The decade of technology is here. As one of the world's fastest growing economies, we are ready for a generational shift. A rapidly growing, digitally enabled, skilled workforce is fueling this accelerated growth. Digitization is transforming lives and businesses as we know them. Coming together to drive this deep tech digital skilling revolution with the Government of India and NASCOM is FutureSkills Prime. Democratizing learning by offering students and professionals an unparalleled opportunity in skill development with NASCOM certificate to give your career an edge. Government of India incentive program to fund your skilling ambitions. Customized course plans to craft your learning journey. Access to NASCOM exclusive career support in the form of job fairs, hackathons, internships and skill challenges. Learner ledger to track your progress. Competency diagnostics test to evaluate your tech aptitude. Opportunity to explore new age tech as well as professional skills. There is something for everyone within the FutureSkills Prime's foundational, bridge and deep skilling learning programs. The FutureSkills Prime learners are taking center stage in emerging tech job roles across industry sectors, with 40% women learners working with colleges and universities to integrate tech skills with the National Credit Framework, aligning popular industry courses to National Skills Qualification Framework. Our learners have gained a competitive edge over their peers. Our strong partner network helps learners make the most of their time spent on the course. Our corporate partners go the extra mile to make FutureSkills Prime a success. Our government partners bring credibility and authority to the programs offered. Powered by the Ministry of Electronics and Information Technology, Government of India and NASCOM, representing the $227 billion technology industry in India with the skilling support ecosystem. We aim to make India the digital talent hub of the world. Let's build the digital talent nation together.
Hi, everybody. A very good morning. And we're back with the Telstra series, and we have so many folks from Telstra. Madhav and Praveen, if you could also come on camera. So today's session will be taken by Vineet, who is the chief. I think. What do you call yourself, Vineet? There out.
I'm principal engineer at Telstra.
Yeah. So it may sound very. Small because a lot of people do say engineer is the starting job fair, but then Vineet heads the whole thing for Telstra when it comes to the research and development here. And we also have Madhav and Praveen who will be also, I think, participating in today's session. And we have Aishwarya who's been, great in helping us in arranging all of these sessions. I'll pass it on to Vineet to give a little bit, brief about what are we going to do in today's session, because we've had multiple sessions so far. I don't know if you guys have joined our earlier sessions, and we are at a level where, we've done so much and we will be going forward. And we'll also have a run through what we did in till today, and then we will go forward. So Vineet, it's over to you. A little bit about you, and then maybe introduction to the session, and we shall start maybe by 11:05 because we do have time. You can go slow.
Yep. Thanks. Let me share my screen and let us start. Can you see my screen? Yeah. Yeah. Can you see my screen now?
Yes, Vineet, you can.
Yeah. Let me move this window to my other screen so that it doesn't interfere. Yeah, I want to see the chats also at the same time. Okay. Thanks, Aishwarya. Thanks, NASCOM, for this opportunity, and thanks to Telstra. This is a great moment for me. Welcome all the audience. We are going to go through some really very simple thing today, which is very interesting. And I hope I would keep it engaging as well for the 1.5 hours. But before I go there, Aishwarya has requested me for the introduction. I'll do a quick introduction there. I have been an engineer now for almost 30 years in my career, seen different, I would say, two different generations of software development. One I could call it as a traditional or old style of software development. Now is the agile ways of working, right? So with so that 30 odd years I've divided into my software and what I've seen as a software engineer. I'm working at Telstra now for 6 years, primarily in the IT sector, IT field, which is around digitization of the uh, B2B segment, B2C segment of telecom for Telstra in Australia. Telstra is one of the rather the leading player in telecom in Australia. Uh, we provide 5G services, and almost we talk about the latest stuff in telecom. We are there in Australia. Also, we operate globally across, I think, 17 countries. We are globally also very much present. Okay, with that quick introduction, also I would like to mention I have done my master's in data science recently at this time. Continue to study. I love studying, and I really find it exciting to share knowledge and also learn in the process. Thank you, and would love to share anything more if we are interested towards the end. Okay, so let me get started. Uh, any specific expectations that people are looking forward to, please drop in the messages that are good to go. I have my colleagues joined with me. Praveen, who's a master's, who's great on the data science. He actually started this whole journey off. And then Madhav, who had taken the session. So far we have learned uh, regression, linear regression. We have gone further ahead when Madhav had taken the sessions on the logistic regression, and we have revised the concepts around metrics and metrics, which are very important. You will continuously see them coming again and again. Today also you will see them, but more from the application perspective, right? So we are continuing that journey, right? And today is the day for decision tree. All right. And thanks, Aishwarya, I missed you. You have been the chain who's been locking us all together to make this happen. So thank you so much. Let me get started. So yeah, I hope you are able to see this screen, and please feel free to post questions. My colleagues and myself will look into this and will constantly reply. This session would be engaging, interactive. I'll not wait for the questions. Rather, please push in the questions as and when you get it. Okay, so we are going to talk about basic concepts, decision tree, and we talk about some metrics which are new in the context of decision tree. And then we will build the classifier, as we will do in every algorithm we have in this space. We'll do the model evaluation, which is a traditional, which we have learned so far. We will see one of the important problems there, overfitting, rules and pruning. We'll touch upon that, then see how do we deal with the continuous variable, and something we'll leave with the what is coming up next. Okay, quiz probably will not go through this because we'll do that on the way. Okay. All right. Time to start on this. I'd like quick typing skills of all of you. What do we understand by trees? Uh, I think I should go back. If somebody of you have read it, that's fine. But what do we understand by tree? Can some of you push answers to the chat? Hierarchy, trunk and branches. Good. Anything that, so graph is also like a tree, right? If you look at a graph, that is also like a tree. So what really tree and graph, where would they differ? Are there some specific qualities? Roots, stem, branches, leaves and nodes, structure. Okay, good. There's some good knowledge coming in. Thank you so much for the enthusiasm. So tree, typically we see that, and all answers are looking good. So there we have the nodes, right? And nodes could be qualified as various types. And then we have branches. We have called stems and branches also in the chat. And what is very important in the context, what we are going to discuss, trees typically don't have cycles, right? What does cycles mean? If you take one node in a tree and we want to go to another node in a tree, you only have one path. You cannot have more than one path without retracting. Are you getting it? Right? In graphs, you may have multiple paths. And if graphs you cut the cycles, then you might end up with a tree, right? And then the trees are of very different types, complete tree, balanced tree, and whatnot, right? And one of the popular implementation of tree you would have seen is, any guesses? Which is the most common tree that you have seen? Sorry, I'll keep asking like this. Be with me. Any example that you would like to share? Binary tree. Good. Good. This is the most commonly talked about and referred binary tree, but we are not going to do the binary tree today. Okay. But then again, I'll ask one more question. It would happen like you are teaching me. Okay. So in binary tree, what, how do you form the binary tree typically? Typically, there are many ways. How do you go about binary tree? Creation of binary tree. Oh, random forest. You are jumping ahead. Uh, okay, in binary tree, at every node you have got maximum of two children, right? Left and right, and the order of traversal can be of any types. I will not go into the primer of the binary tree, but that's how it looks like. And there's a criteria that we have got. Right, you're right. So that's the criteria we have got, that on the left side typically you have a value which is child nodes, which are having lesser value than the root node, and the right side is the greater node. This is a typical binary tree we have seen. Okay, going forward, so trees, as we know, as we have seen now through our discussion, they are primarily to organize information to help in the search of a particular node through the tree in a logarithmically reduced uh, length. Okay, a length, a depth of the search. Okay, now coming on to the next little bit further on this. Um, so node we have known, right? The nodes are further having the nodes, but there's, in our context, we are going to talk about not only two nodes, there can be many nodes. And what, on what basis there can be more than two nodes? We'll talk about that as we get into the details. Then there is a root node which doesn't have a parent. There's a children, of course, and then there is a leaf nodes. Leaf nodes are the nodes where we do not have further branches, right? And the criteria is in which you decide the data point, where does the data point goes. Is it going to be on the left, or the first child, second child, third child, or fourth child, right? That kind of, that is the criteria that we are going to use in creation of our tree. Now this diagram I have taken up from the notebook. Okay, we are going to program, not going to go the usual route of PowerPoint, because I think we have learned enough and we should now apply the skills in this session. Okay, I would request all of you, if you can open your Jupyter notebooks on Google Colab wherever you are comfortable, or stay lashed, because there will be enough gaps in the session, right? So you should be able to catch up. Okay, so this is how the tree would look like in our context. There will be a better representation coming up later. But the idea is there is a root node where all the data samples are together. Okay. So we have 1 million samples or 100 samples, whatever samples we have got, we have all of them together in the root node, right? As we go further down in the tree, this root node, this set of samples are going to break down into different subset of samples. Okay, right? And that would be based on certain criteria, right? That criteria I'm putting it as b, that particular value I'm putting. So we select some criteria, but that criteria would result into certain values, and these values further divide the tree into, this is the subset of the samples. So you don't see the subset of samples coming straight away below here. Okay, so there are three branches and there can be many more branches depending on the context we have got. Let's take an example here on the right. This will make it easier, and we'll continue with this example, which is a very popular example if you go on the internet. So but this is easier to deal with in the session. So we have a problem at hand. There's a question that we want to ask. with the players, whether the players are going to play today given these three parameters, which we call features. Remember from the past sessions, for every data sample, we have got a feature set, right? We call this attributes, features, or we call it as X value, right? And the Y value here in this context is the target variable is, anybody? I just spoken about it. What is the target variable in this case? Is the objective, right? Yeah, tennis is to be played or not, right? So, and the features are, can you make out from the features from the tree? What are the features? We have outlook is one, no, not sunny rain. So we have outlook as one feature, humidity as another feature, and wind as another feature. Yes, you're right. And these features can take values, multiple values, which we will call as classes, right? So outlook can take three values, that is sunny, overcast, and rain, right? If it takes sunny, then the whole of the data set would get divided by the samples which have got only sunny value, right? So in this place, you would get all the variables which have got sunny just above this. Okay. Now within sunny, we take another feature variable out of that subset, that is humidity, and with that humidity, taking these two class values, that is high or low, that subset gets further divided into the subset, right? And within every subset, we would get a variables, whether it is here or here. The samples would have the target variable which defines whether the tennis would be played, yes or no, right? That's how this will be organized. If let's say we are left in this particular leaf with the samples, let's say 10 samples, right? 8 of them have a target value saying that tennis will be played, and let's say 2 of them samples say that tennis will not be played based on the data that we have got. What should we conclude? If a new data sample comes in and we traverse this tree, so we look at the outlook, it is sunny for this new variable. We look at the humidity is high, and over here the historical data says 80% of the samples are telling that it is no, we cannot play. So we will go with the majority result. Perfect. So that is how the prediction will take place. So if you look at this, it will also appear like set of rules. If the outlook is sunny, then look at, if humidity is high, then the majority is no. So I will say you will not, there is highly likely that we are not going to have a tennis game. Okay. So let's let's go further into the notebook so that you don't end up sleeping in the session, right? Why my this thing has gone? Wait a minute. Yeah, I have to bring this back here. Okay. So we have talked at this point. Any questions so far on the tree? I hope all is good and very simple. Few yeses will help me. Yep, perfect. Good. Thank you so much. So let's map it to the programming. What are the problems that we see? What are the problems we see in this theory so far we have done? So we have done the decision tree, okay? That is as simple as that what we have seen till now, okay? We are going to get a little bit more complicated, but what is the most important problem that you are programmatically, what are the problems that you see? Theory is not going to work in the industry, right? We have to program it up. Any thoughts? Oh, my voice is gone.
No, we can hear you. It must be their problem.
Okay, so please check your mic. I'm looking at your voice chats all the time. So, yep. So, what are the problems that we see? Okay, I'll not wait too much further, but I'm throwing the questions. Please do engage. So, we have a problem to create this tree, and there is also another problem which is more complicated. Let me mention that we are going to get into a situation of tree of trees. Anybody who can visualize that there is going to be a problem of tree of trees, and that's the problem that we won't have seen it before. Okay, but I'll not wait for this, but let's go further. So every node represents collection of data points, we know it. Every node represents this collection and a feature on which the test would be conducted or the criteria will be used, right? And the test results into the subset of the data points. Each group can signify an outcome when we go further deep into the tree. Okay, so we will need pandas, numpy, and scikit, sci, scikit-learn. These are the three libraries we are going to use. Okay, so we are using three features as we have discussed. There are going to be 14 data points which I have manually entered. For the sake of this discussion, I can post this in the chat for everybody to pick it up if you want to, right? So, and if when I do a df dot head, yeah, we see that this is in a useful data frame, and yeah, this is in the 14,3, that is 14 is the rows and 3 is the columns. Though you will see that I have got an additional field called temperature, which I'm not using it right now. We have kept it towards the end. Okay, we are going to bring that in later on. Now, so we have fed the target variable also here. So let me also push this to you so that how many of you have got your Jupyter configured or are able to use Jupyter, so that I know how fast, or you're not receiving data. Okay, just be with me, focus fully on this, ask questions if you're not configured it. This okay, fine. All right, so I'm just going showing you now 14 rows are there. This is all good. Let's go further down. The first concept that I'm bringing it up, okay, with me now. I'm not going to do programming for next 5 minutes. Data set is not in the form of CSV right now with me. So I've shared the the command for the data array. If you can use that, copy paste it. Oh, I'm actually pasting it to. Oh, yeah, that's a problem. I am sending it to the. I should send it to everyone.
Vineet, have you shared any link of Colab library
No.
or no?
No.
This is on Jupyter Notes notebook that you're doing.
Yes. I haven't shared it. That was a bit missed out. I'll share it after this call. Okay.
Vineet, I have shared the data set. You
Okay.
can go ahead. Yeah.
Yeah. Perfect. Thank you. And yeah, we don't have the shared INB. Okay. I'll keep sharing the snapshots. I think you should be able to see it. And earlier I was not sending it to everyone. Now I think everybody should be able to see what I'm sending it across. So entropy is the most important thing. So what happens if you have a sample which has got, let's say 10 data points, and 5 of them says tennis will be played and 5 of them says tennis is not will not be played, and given the features of wind, humidity. So what do you say about this data set? The 5 are saying yes, 5 are saying no. So it basically means, if any responses, or have I lost everyone? Okay. Yeah, so this is the maximum randomness. Perfect answer. So this is a common man's language. So randomness in technically in dysentery, what we will say, it has the highest entropy. You would note that this is a concept that we have studied in the physics. So typically an atom or a molecule has the molecule has the atoms in a maximum randomness, or the entropy increases when you have a gaseous state. So there is no particular order of the atoms. So not getting copied. Yeah, please, those questions will be answered by somebody else. Stay on the topic, please. Okay, so So now what happens is, this is the root node where we have all the data together, and 50-50 is the ratio, which is the highest randomness, and the entropy value would be considered as equal to 1. Perfect. Now the entropy has to be measured in some way, because that entropy will be used as a criteria in our formation of the decision tree. Okay, and that will be applied to that sample set, not to the feature. Remember that. Okay, this entropy is applied to the target value, because that's what is playing up in creation of the trees. That's what is divided amongst the samples. Okay, now I'm referring to a textbook for the sake of authenticity, and I'm seeing myself. Is it uh, okay?
No,
Are
we
you
can see your screen, Vineet.
okay? Okay. So now in this context, this entropy measurement is based on the probability. What is the probability? We have got 50%. Yeah, 50% divide 50% is the probability of picking up yes or no, right? So that probability becomes zero point 0.5. That probability is used in this formula. This is how the decision tree uh, use of algorithm started, and then we have other parameters also, metrics also. So what is this happening? I equal to 1 to c is the number of classes, the values that that thing can take. For example, in outcast we have got three possible values. What are those values? Overcast, rain, and sunny. These three are the classes. So the summation will vary over 1, 2, and 3. That is sunny, rain, and overcast. And we will sum for those respective probabilities multiplied by the logarithmic base 2 of that same probability. And that will give the entropy. And if you use this formula, if let's say we have got 100% of the samples are yes, the entropy is 0. Automatically it will come to 0. Okay, because logarithmic 2 base 1 would be 0, or otherwise the probability of the other samples will be 0. So finally the entropy would be 0. That's how it will work out. Okay, this is just to test quickly entropy. Any questions on the entropy so far? Yeah, I will share the Jupyter notebook. I will share with Aishwarya, and that would be up to NASCOM. How do we do with this? Okay. Yeah, please come on the topic. Any other questions? Please repeat the formula. So let me do one thing. So yeah, xkellydraw.com. This is a little detour for my session. If the formula is a bit of problem, it is confusing. Uh, no doubt about that. So what we are saying is, we have got samples, right? We have, what is the probability of, let's say, out of 5 we have made 2 are red. So what is the probability? Pi, p of red. What is the probability? 2 upon 5, right? What is the probability of black? It is 3 upon 5, right? So now what we are going to do is entropy. How the calculation will look like? Minus 2 upon 5 multiply by logarithmic base 2 of 2 by 5 with base 2. This is how you will write the data in your calculators, right? And what would be the next term? The next class is for 3 by 5, right? And star log of 3 upon 5 with base 2, right? Does it help? Yeah, the class has started. We are on the first topic of entropy. Just be with us. You should be able to catch up. So if we calculate this will return us the value of entropy. Does this clear the formula? Okay, I'll use this whiteboard to explain things which may look difficult there. Okay. Yep. I'm moving on. Let's. This is the tree that will get formed typically when we are using the data. I'm using some random copy of the working of a decision tree. So what will you see is this X is the set of attributes for a given sample, and it apparently has got 27 or 27 or probably 100 features. Okay, so the 27th feature is used as a criterion, and the top sample has got 3388 plus 3111 as the total number of samples. He is using in the first branch 27th feature, comparing it with the threshold value of zero point 0.5, and then creating a entropy between the classes that have got created, which has resulted into an entropy of 0.99, basically completely random data set, and the total samples are 6499. And now when this, based on this value, it has divided the two subset, divided the complete data into two subsets, right? And similar thing keeps going on, right? This is how the tree starts forming. But we are not talking about tree of trees here. So he has decided arbitrarily or on some basis that 27th feature has to be used, right? That's a problem in the decision tree. Which parameter do you have to use, right? Entropy, I think you should refer the recording. uh, I understand. Maybe when we go further, I'll try to recap on entropy. This is a very important concept for, as we go further. We are going to look at the program. You will understand it. Okay. So let's look at this. Okay. So what are we doing? We are writing a program of calculating the entropy given a subset of data. Are you able to see this is readable on the screen? Yes. Okay. So what we're talking about here is we are talking about a subset of the data. On the root, it will be the complete data, right? And we are talking about the target on which we are going to do the branching, okay? On which we are going to compare, right? For the calculations. And what is the truth value? I'm considering there are possible two classes in the target variable, not in the features, the target, right? The Y, which is, what are those two values? Yes and no. Okay, so the truth value we are going to compare for all the values of the data samples for the target variable, and we have the sample set. These are three things given. So we start with the total size is, we take the sample, the shape. We know the first parameter of the shape is the number of parameters, right? If you remember, we have done this df dot shape. The first parameter is the number of samples, right? So we are taking that as first. Let me copy paste this particular thing so that if somebody is working through the chat, working through the Jupyter, they can copy it. So now the positive samples, right? The positive samples are those which have got target variable equal to yes, right? So what we are doing is sample set, the data frame that we have got, right? Take the value of y. Y is the name of the feature set, is the name of the column. Okay. So let's say our column is play, right? So sample set bracket play is equal to yes. So that divides the whole set into the positive samples. So we have got the positive. Oh, you can't copy from the chat. Okay. That puts me into a little bit of problem.
Try copying it on a notepad first.
Okay. Yeah. Please figure it out because we have a limited time. I'll go forward, not get into these issues right now. Okay, positive. So we understand the positive samples. So we are comparing all the samples with the truth value. If they are matching, we treat that as a positive value, and then we are dividing that with the total, right? That is 3 upon 5, the way we have done it in the, remember we have done this in here. 3 upon 5, this is, let's say if I taking, if I would have made it yes and this is no, right? So this is my positive samples, and this is next, second one is the negative samples. Okay, so the similar way we are calculating the negative samples. All right, and this is getting printed every time just for the sake of debugging. Now let's come to the calculation of entropy. Those who have missed it before, let's see that again. So entropy consists of two components, clearly, right? Because we are talking about two classes. two classes in case of the target, because that's where the sample is measured for the entropy, right? So two classes, yes or no, right? So there are two components, p for yes, log 2, p for yes, and then p for no, log base 2, p to no, right? So the same thing I'm doing here. So if positive is not equal to 0, because if it is equal to 0, I cannot do 0 log and can create a problem. So what I'm doing is positive, the probability of the positive multiply by the log base 2 of the positive. That's the part 1. The first class, that is yes, right? The second class, which is negative, what is it? Negative in multiply by the log 2 of the negative. And then I have added also the previous value into this, right? So I get a total entropy. Good so far, right? I've revisited the entropy again. This is how we are doing the calculation. And then what we have done is we have captured all these important parameters into a Python object, right? Where it's a dictionary in Python. So we are storing for this particular node for which we are calculating the entropy, how many are the data samples, how many of them were positive, how many of them are negative, and what was the class entropy for that sample set, right? And I'm trying to reconnect this with this node, right? What is the entropy? How many were the samples? How many were positive? How many were negative? And don't confuse this division based on the features, right? It is the target based. Sorry, this positive and negatives is based on the target. Okay. And if suppose 637 is the positive, which is the maximum number, so any node, any sample that reaches till this point will classify it as positive, right? This will keep coming. Okay. So can I move forward? Is this concept of entropy is good? Entropy leads of overfitting or underfitting. Entropy, see, entropy directly doesn't contribute to overfitting or underfitting. We are jumping a little bit ahead of the session. I'll cover it later on. Okay. Entropy measures the impurity. Yes. Yeah. Sorry. Yeah. Thanks, Praveen. All right. Moving on. Since Praveen is responding. Uh, So we are taking an example here. So we are giving the attribute play game, which is our target variable y, and we are using the truth value as yes. And we have calculated the entropy for the complete data set, that is a data frame, and we get number of positive samples. Sorry, the positives. I'm not counting the samples of the positive, rather I'm calculating the number of samples divided by the total, that is the ratio probability 0.64, then 0.35, and the class entropy 0.94, which basically means if we have the target variable has got nearly 50-50 division between positive and negative samples. Okay, this is just an example to show this routine is working. Let me run this so that I should not face any error later on. Oh, it has resulted into an error. What has happened? Why it has? Yeah. Sorry, this has gone little awry because I'm not executing all the things every time. So yeah. So this has worked because the DFA got corrupted. Let's go further down. So I not started creating the tree. This is just to give an idea about how we are creating the tree. So what have we done? We have created this node, which is telling that for sunny class, I've got the entropy. If I look, select outlook equal to sunny. So now what I'm doing here, what am I doing here? In the first argument, if you look at the get entropy function, in the first argument, we have to provide a subset of the data, right? So what I'm doing here, I'm using the subset of the data by comparing Outlook column with the value Sunny. So I'm picking up that branch of Outlook which has got class value as Sunny, right? And for that, I'm going to use, again, the target variable stays the same. I'm going to get the entropy, right? I'm also storing the class name because this will indicate that this whole data is coming from the Sunny class, for the Sunny class. And this is where I get the first node. The similar thing I will do for rain. So now I'm doing 3 branches, right? One branch we are getting for one class value of feature. What is the feature? Overcast. Oh, sorry, Outlook. Please do not get into threshold. That's a continuous variable thing. Will come little later. Okay. That was an example, 27 features or 53 or 100 features. It can become as big as that. Okay. Right. Okay. Right. Thanks, Praveen, again. Okay. So what we have done is here we have used the other two class values of feature called Outlook, which is sunny, and then another Outlook feature we have used is rain. And this has given us entropy for the respective subsets in here, right? Let's try to create this together. I'm going slow enough so that you are all able to get it. Okay. So we had the root, right, which had got samples of 4, and we had the entropy of 94, right? Then after that, what we have done, we have taken another one, which we have taken a feature, sorry, we have taken a, let me make this square. We have taken a feature called, what is the feature we have taken? Outlook, right? And within Outlook, we have created a samples. One sample is for the sunny, right? Sunny is, right? Another sample we have created for rain, and so on, right? I will not create all of them. So are you getting this thing? Now what else can happen? Anybody? Quickly. I'll try to pick up the pace because we are already quite a bit into this session. Anybody? What else can happen in this tree? No, this is not my root node. This is one of the branches now. I've taken Outlook as one of the features. Okay, now it is Outlook is my root node. Yes. Thanks, Praveen. But initially my root node was here, and as I move through the algorithm, my root will keep moving next. But I would, when I have to start again, it will be again starting from here. But what else can be happening here? Right? We probably can select, instead of Outlook, we can select wind. Is that right? And also we can select something else, but we chose Outlook instead of wind and humidity, right? Any guesses? Why would we do it this way? Why somebody should do humidity? Why somebody should do Outlook, not wind and humidity? Right? And one tree is getting formed here, another tree would get formed here also, right? Things will get complicated if we are talking about 100 features, right? We can't even draw. So I'm looking for an answer on what makes us think that Outlook is better than humidity. Why? The question, Prasad, is why should I select Outlook over humidity? I've not answered it. I'm just, okay. Some people, I'm just testing how many of you are actually learned decision tree already. Good. Good, you still have the enthusiasm to refresh your knowledge and perfect. So somebody has given the answer. This is called information gain. Okay. So now coming back to our screen. Okay. So you know what I have done? I have done the branches, the 3 branches. We'll come to know information gain. That is our goal in the next 5 to 10 minutes. Okay. So we have done all the 3 branches: sunny, rain, and the other one. And for the subset, we have got the entropy also. 0.97 is the entropy if we select sunny. 0.9 sorry 0.9, yeah, for rain it is, there's something not right here. So let's see, 0.97, and then we have got, yep, and then we have got the overcast entropy also, right? So we are getting somehow strangely the class entropy for sunny and rain is 0.97. Both of them are same. I didn't notice this before. And overcast is 0. So what my decision is, out of the 3, the subset of overcast is more homogeneous, right? But I'm not going to get into that. There's just a interpretation piece. Okay, let's put this together. We have to reach to the information gain. So if I select Outlook as the root node, as Praveen mentioned earlier, right? I have got 3 possible classes, and for them, these are the entropies, right? Now what I have to do is, I have to do the, since my classifier, the differentiator was, what was that? Outlook. I need to calculate, has Outlook helping me to make a better prediction? And that measure is information gain, right? Or it can be humidity or wind, right? Let me repeat again. My question is, if I am selecting Outlook as the differentiator and not the other, if I'm selecting Outlook as a differentiator and I've got the entropy of all the subsets, is it helping me reduce the entropy or the impurity compared to if I select wind or humidity? Okay. Is Outlook helping me to reduce impurity? That's the question I have to solve for. Okay. And what would the reduction of impurity is? That would basically mean information gain. Reduction of entropy means I am more informed. I am better informed than I was before. So that is the reason it is called information gain. Okay. In a very layman's language. Okay. Now, how are we doing this? How are we doing this? Again, something similar to entropy we are going to use. Okay. This, before I get into this formula, let's do this. So let's say we have entropy E1 here, we have entropy E2 here. Okay, we have number of samples N1 here, and we have number of samples N2 here, right? So what would be the effective entropy that is there if I used Outlook as a differentiator? It's a very simple formula. Some of you would know this already. Anybody kind of compete and write that in the chat while I am writing here? Okay, so it would be N1 divided by N1 plus N2 multiplied by the entropy of E1, right? And I would ask one more question here. Okay, what does it look like? What does it look like? Any familiar mathematics concept here? I'm using N1 divided by N1 plus N2 multiplied by this entropy and this entropy. What does this mathematical concept look like? So you are not able to see my Excel draw. I'm sharing the entire screen.
We can see it, Vineet. It's
Okay.
visible.
Yep. Any others? Marginal probability, yes. I'm forgetting it a little bit, but probably true. No, there's something very simple. Weighted average, right? We are adding the weight of the sample. Oh no, no, Guinea, you're going ahead. I want to rush. Okay. So yeah, weighted values. Okay. So this is as simple. I'm just making it sure that you will remember it for longer time. Okay. Now this is so this is the code. I'm going to paste it again so that you guys can, if somebody is following me on the Jupyter, you can do it. And yeah, I don't know whether if I had done the previous one, get entropy call was like this. Okay, this might be easy for you. Okay, so coming back, calculate the classifier entropy. The classifier here in our example so far we have taken is outlook. So what we are doing is we are calculating the total value. We are appending the children. We are also calculating the children. We are creating the nodes. So we are getting the entropy for that subset where feature is equal to the value. The feature can take three values. So we are taking, let's say, feature is outlook, outlook equal to rain. And that for that we have calculated the entropy and saved it. And again, the target variable remains the same. And that value is reused here. So we have seen how we are going to create a node. So we are creating a node here and appending it to the children. Okay. So we will see, let's run this so that we see it working. Okay. I think I will not run the cells later on. This for some reason is running very slow. So what is happening is we have used the feature outlook. We have calculated that weighted average feature entropy the way I have explained earlier. And then there are children's in the array. First children is sunny, right? Second children is overcast. Third children is rain, right? Sunny has got 0.97. Overcast has got 0 and rain has got 0.97. And then based on these values, we have calculated the overall feature entropy at 0.69, right? So we know that this is going to give us the feature level entropy. We go further down and we calculate this again with the humidity, right? Had we taken humidity as the path, then what is the entropy that we would have got? 0.78, which is a higher entropy than outlook, right? The same thing. So let me copy paste this particular thing. Yeah. So all right, so humidity gives us a higher entropy, which is not good. We use wind. Wind also gives us a higher entropy, 0.89. Not good. Okay. So what are we going to select? The one with the lower entropy, that is overcast. Now we have a reason, sorry, outlook. Now we have a reason that we should go with outlook as a discriminator. Okay. So now we see the difference between the entropy at the start and after using the differentiating feature. Clearly outlook as the thing. Now we are able to understand this, right? We have got trees, tree of trees, because this is being differentiated by a feature, and we are selecting one path. We are not going to come back to this path now. We had selected humidity and we are going forward. Okay. And there's a problem that gets created, defined here, and I'm just touching upon it. That becomes a separate area of work. How do we solve this tree of trees problem to find the most optimal path for our uh, model okay, and that would get covered in the subsequent lectures. Yes, Bhaskar, you're right. N1, I've in the example I've sent, N1 is coming from yes and N2 is coming, no, wait a minute. Okay, you're confused. So two things, let me, others might have also done the same thing. So this thing was different. Okay, this was file calculating the entropy. Here we are simply doing the weighted average. Let's say if I had got another one, right? I have got overcast, right? So I will get N3 also here, right? I'll get an entropy E1 here, sorry, E3 here, and N3 here. And my formula will change, isn't it? Bhaskar, is that better? So this is not related to yes or no. This is related to these values, right? Okay. Okay, so in the question answers. Question answer, nobody's posting. I think my colleagues can do that there. I think chat is going to work for us at this point. Okay. So let me move forward. Question answers, nobody's typing in there. People are not lashed to that one. So we have solved one other problem, that tree of trees. Rather, we have touched upon this particular thing. And this is something that you can research and look forward to the next sessions when we are talking about random forest and other things. Forest itself means tree of trees, or rather forest of trees, right? And this is not exactly in this format, but it will be something else. But the point is there are multiple trees to work with. Okay. Now we are going to go forward. So what we are doing is we are creating a tree with the root with this one, and then the feature junction of Outlook, right? And we are creating the tree of trees with Outlook as well as humidity and wind. We're actually keeping all the trees together. Okay. This one is going to create a tree for Outlook. This is going to create a tree for humidity and so on, right? And we have printed this also. This would be not so easy to read, but I'll just help you with what it looks like as you try to do it on your own. So we are starting with the root. We are talking about a feature junction Outlook, and this is an array. When we close this particular thing, we'll get another feature humidity, and then when we close this, you get another feature called uh, wind, right? We get another feature called wind, and under that we will have children. Okay, weak and strong. So okay, now comes the information gain, the goal that we had. Okay, so this part of the thing we have seen, right? How do we calculate the entropy of the subset which has got different classes of children, right? We have combined all the children using weighted average value. Now that value is subtracted from the root entropy. So feature, that is Outlook, is being used, which has helped in creating this effective entropy, right? But it is derived from root, where the entropy was 0.94, right? And the difference between the two would be maximum if this entropy value is low, right? So basically we have helped by selecting feature called Outlook to reduce the entropy, and that particular, this difference is called information gain. We have seen this was just a repetition. So this information gain we are talking by subtracting exactly by this formula, right? And we are using 0 is the Outlook, then 1 is the, this indexes are 0 for Outlook, 1 is for humidity, second 2 is for the 2 is for the uh, 2 is for the humidity, and 1 was for the wind. So anyways, so the information gain is lowest for the humidity. Okay, we move on. Let's select the sunny case. We are going a level deeper and then we will stop there. Okay, so we are selecting one further down in when we have selected Outlook, and now we are going to look at the sunny as a branch. Given that branch, given that branch, sorry, given that branch, the subset of data becomes this much, right? We had 14 samples, we are left with 5 samples here, right? And Outlook is sunny. So this parameter has become useless for us because we have consumed. What are the two parameters left? Humidity and wind, right? Now we are going to use that as the further, which one is better? Humidity is better or wind is better? The same question we are going to ask, which we were asking in the Outlook, right? So, so what we are doing here is we are taking the attributes of sunny node, which gets us the node attributes. Any questions you are putting up? Yeah, any questions so far in the entropy calculation information gain? Let me take a pause here. Yeah, while I wait for any questions, let me save this. No, this will.
Vineet, they're asking for explanation of weighted average.
Weighted arrays again. Okay.
Yeah.
So So the circles, do you understand, right? These are the examples, or we call it data points. Is that right? Is that okay? Anybody who can interact, say yes or no, so that we just flowing along. Shraddha, I'm talking to you now. Yep. So these are the example data points. So circles are example data points, and this should also be example data points, right? And this is the feature. We may better call it as a discriminating feature, right? Or a classifier. Okay. So far good. We are not mixing up the two nodes. Okay. Now what is happening at this point? We were calculating the entropy. Entropy calculation is okay with you? Okay. So 0.94 was the entropy, which basically means nearly 50% of the samples are telling you play, and 50% of the samples are saying you don't play, right? It is as good as tossing a coin. So if we do not create a tree and we use this sample for prediction, it will be no machine learning here, right? It doesn't do any good to us. So we have to go level deep. So we are selecting outlook as first discriminating feature, right? What are we going to do? We are going to pick up all the samples in 14 which are having outlook equal to sunny, right? Let's say they are 5. Outlook equal to overcast. Okay. And then we are going to take another set of samples which are going to be, let's say, where the feature value of of outlook is sunny, and the remaining would be in rain. Good so far, right? Right. Right. Now in these five samples, let's say 3 are saying yes and 2 are saying no. Good. Okay. Out of these 6, I'm just taking example because I'm not referring to the code right now. Okay. 2 are saying yes and 4 are saying no, we will not play, right? And let's say here 2 are saying yes and 1 is saying no. With me so far? Okay. One interesting thing. This decision tree looks very simple in my exam. Okay. I made a mistake here and I got 0. It gets so confusing. Okay. So, and then say, okay, why couldn't I catch it? Okay, this is as simple because we end up using 5, 6, and 3, and we wonder how do I calculate the values, right? But once it is inside the program, you don't have to worry, right? But that's where the dumbness starts to come in. Everything gets sit inside the program, and then we forget about what the mechanics happen behind. So 5 is the number of samples, but it is not telling us how many are yes, how many are no. For that, we have the second piece of information which says 3 are yes and 2 are no. What is yes or no? Whether the persons are going to play or not play tennis. With me so far? Right? Okay. So now what we are going to do is these 3 and 2 are not going to be used. Okay. This was just to get a clear picture. We are going to do some calculation now. In the first one, 5 upon 14 star the entropy of 3 upon 5 star log of 3 upon 5. Is this the right way of doing the entropy? Minus 2 upon 5 star log of 2 upon 5. Is this good? This is the entropy and this is the first part of the weighted average. The second part, what it will do? It will do 6 by 14 and do the calculation 2 by 6. 2 by 6, right? I'm just tempted to take the exam here and see if I was the odd one to score 0 in this. right? And how many of you are able to? Okay, so and this can further scale. Okay, yep. I'm not going to do the complete calculation as I'll lose my teaching time, right? Are you with me, Shraddha, so far? Shraddha and Nayak, right? Okay, thank you so much. So let's move on. Yeah, you can do the calculation, use the calculator. That is the most important thing. Programming makes things and interesting, but then we forget after that the concept, and it keeps happening with me, right? Because once you write in a program, then you call only the function. You don't remember the concept. Okay, so let's go forward. So we have talked about the information gain. Where am I? Yeah, all good. So I'm getting a lot of yes, so I should move forward faster. Um, so what we are doing is we are trying to now uh, create the tree here. Okay, I think I was trying to create the tree somewhere below. So sorry, I've kind of jumped over. Yeah, we were calculating so we are now what we are doing is from the original tree that we were trying to create, right? In that we are getting the children 0 because 0th place we had kept the outlook. So we are uh, sorry sorry so we are using the sunny we are using the feature that is outlook, and we are accessing the children of that, which becomes the children root, and in that root we are getting the 0th, which is sunny, right? This is how we are going to interpret. Okay, and now for the subset of the sunny we have got these many variables, out of which 3 are no and 2 are yes, and of course we now forget about the concept and we call the function only, right? And then we are calculating the gain, right? So we are getting the gain. This is the least gain when we are using the wind as a subsequent feature discriminator. We are going level below, right? If I go back to the previous one, uh, we are going further down. Okay, let me move this on the side. So what we are doing is we are creating another feature. I'll share this Excalibur also. We are going here, right? And we are probably going to select humidity, but there can be one more branch that is a windy, right? Okay, and then we are going to have similar way subsets depending on the classes humidity can take. How many classes it can take? It can take high humidity and I think low, right? And the same calculation will start repeating, right? Are you getting this tree? This is not the picture you saw in the diagrams, and maybe you will not find it in the on the internet also. Okay, so and in not in my IPINB alpha file also. Okay, so yeah, this we are just doing it in the class. All right, so we have gone really in deeper 2 levels to ensure that we understand both the concepts of entropy, information gain, and branching of tree of trees. These are three, four concepts. And tree of trees is something that we are going to catch up more as we go to the next session with someone from our team. Let's go further. I'm now skipping this part. Any questions so far in the meantime? Okay. So now what we have done, we are building some algorithm, right? We have kept it very simple. But this is really an algorithm that we have evolved, right? And this all looks common sense. But the moment we start to do it all over again without any reference, we'll falter, right? So, but this is really something that has been done by the researchers in some time back. So this is called ID3 and the variant of ID3, a simplified version of the ID3 algorithm, which is captured here, which is an iterative. Because in tree, typically you get into iterative way of working. As Praveen mentioned, that was a very, very important comment that Praveen mentioned. as you worked on this algorithm, you had to shift your route to the next level, which becomes your base, and then you calculate the rest of the children. And in the process, you create a complete tree. And that can be very complicated as well. Now, what is very important, I will not go through this example. This is pretty self-explanatory. Okay, you will find that one important thing. This is the iterative recursive function. Okay, why I'm saying recursive function? This example is a subset of functions. Okay, how is it happening? If you go in this particular example, you will find that it is calling itself again with the same thing, right? Target attribute that I told you. The target is a play game. Examples is subsamples, and then the remaining thing is passing just so that it can handle the remaining part. And it is returning the classification. Classification is based on what is the majority what is the majority value of the target variable in the subset, right? That is how you predict. Okay. At this point, yes, I would get into the Guinea, right? Entropy is good enough for us for generally our programming, but we have option of Guinea because it makes the programming more efficient. We are using a logarithmic scale there, and here it is pretty simple. You would find that we are using on probability that to ones and just doing the square of it, right? A simple mathematical operation, unlike a logarithm. So this works out much more efficient computationally, and also it is not very steep. It is giving more spread, kind of. It is not creating. There are some advantages or disadvantages. I'm not very uh, clear on that, but generally entropy is giving you enough good results. Okay, right. Now this is all about impurity. So we are subtracting it from 1 minus 1 value. Why? Maximum probability what can happen in our case is 0.5, right? If you look at the the probability across, right? So what happens is when we do a square, right? So 0.25, two classes, add it up 0.5, and if you if you minus it from 1, it will result into a maximum value of 0.5. That's how it goes. It doesn't achieve a 1 value. So if it's a completely random number, a random set, the probability is 50%, and that's where you get into zero point 0.5 square, 0.25, and 0.25 added becomes 0.5, and that's how Guinea. So Guinea you can use. That's one important thing. Now let's come to one very important thing. There's something called depth in the tree, right? If suppose you keep going deeper and you have enough number of attributes, what would happen? In your leaf nodes, you may have subset of only one variable, or maybe two data points, or one data point, right? Is that a good scene? Is that a good scenario to have? Anybody? Now the time for people who were saying overfitting. So can you put us some explanation? Is it a good, not good? Why? I want to learn from you. Okay, let me put my thoughts here. Yeah, computation time will become more because you're getting deeper into the tree, but you become more specific, right? To what? Specific is to something, right? What do we mean by overfitting in this case? We had seen the comment earlier. Yeah, every data point is captured, but what does it mean? Too much variance. Let's bring it down to the common man's language. What does it mean? Sorry, Aishwarya, can you, Aishwarya or Anjana, if I'm running over time and I'm not looking at the watch, let me know.
We have 20 minutes, Vineet.
We have time, Vineet.
Okay,
Yeah.
I'm probably nearing the closure also. So please, come on, use your brains. We want to bring it to the common man's understanding. What happens? We can be overfitting, the variance is high. What does it mean? We are fitting every data point. What does it mean? So remember from the previous sessions, when we have to train our model, right? We are talking about decision tree as a model. No, you're not getting there. No, overfitting is a very high level term. This is a data science term. Let's make it very easy to understand. Okay. So what is happening is we are dividing our data points into, yeah, it becomes complex. It becomes complex. But we are dividing the complete data points into what? Training and validation set. How many of you remember this concept? when we have to train the model? Yeah, training score will be more. Why? Because we have created a model which addresses each and every data point, right? So what would happen? We have a higher score in training. So how does it matter? I'm covering the text part that is going to come later. So yeah. So let's say training, I fitted every model, I've created a deeper tree. What does it mean? I would have an accuracy of 100%, right? In the training, because every data point is captured. Yes or no? So what will happen when I do the validation? Yeah, Vishal, what would happen when I do the validation, and why would that happen? It would differ, of course, it would differ. But let's say I have achieved 100% here. How much it could be in the validation, and why? Remember, when we have split the data in training and test in the validation, we have done a random sampling, right? Yeah. So validation could be lower because in the training, which is a larger sample, if we are trained for every data point, there's a this is true for every data set. There would be a noise in the data set. Okay, noise basically means the wrong data points. If we are training our data, if we're training our model to the data which has got noise, we would actually be creating a wrong model, which is fitted and suitable for only training model. In the real world, when the data comes to us, we try to fit into that model, it will result into wrong results, right? And that results into a lower accuracy. Are you with me? Say yes or no, right? And that causes a variance, right? So this way you have seen this variance term earlier. You have seen this validation and training samples. I'm just refreshing it. Okay. So now this is the problem that happens when you are going deeper into the tree. You are just fitting every data point, and this is no good. Okay. So depth is important. All right. These are the parameters that you will find. So what we have to do to fix this? So the great yeah, before that there's something that I missed, that is a split information. There's another parameter. So for a feature we have seen 2 classes, 3 classes, 5 classes, but there can be situation where people have created 10 classes in a feature, right? That also what it does, it do, it may create classes with one or two fewer samples. It would improve the accuracy level of the training. It hurts our model, right, on the similar lines. So what should we do? We should adjust our information gain. If there's a larger spread of the classes, the information gain should be reduced relative to the other classifications, right? That adjustment is called that adjustment factor is called split information. And that when divided for adjustment, when we divide gain or Gini ratio with this split information, it helps us get a better gain ratio, right? If the gain ratio is higher, then only we select a particular feature discriminator. This is only adjustment. In case we have a data which has got features which have got larger classes, we should use this split information to ensure that we are not selecting a feature which is not adding much value and may spoil our tree. Okay. So going further. Okay. So um, I'm now moving into a very quickly. This will not take much time. So please copy this and be with me. This can be a fresh note for you. What we are doing is we are not going to the basics. We are straight away using scikit-learn. All right. Everybody with me. If somebody has open notebooks, you just use it. So we are using the classifier, distinguisher, parameter, or metric as entropy, right? And we are doing the split between all of them, right? We have talked through all of this. And sorry, this is looking so odd to me now. Wasting the thing, I should have shared IPy and B before. This is really not a good use of time. So what is happening? I'll stop here. So I've done the import, right? I've done the XY, I have done the DT classify and done this export. And then I had done this decision tree, which is the key function here. And boom, this gives me an error. Anybody who can predict why this error has come. Quickly. I can't paste in Q&A section. I will lose track of your messages. But stay with me then. Why this is giving an error? Let me show you the error here. Anybody who can give me a guess? Quick guess. This is the error I'm getting. Have you seen this error? Anybody who can tell me why this error? And this is the important part. This is an important concept, which is, yes, label encoding. So Vaishnavi, you should, yeah, you can be helping many. Yeah, thank you so much. So label encoding. What do you mean by label encoding? Okay. So for example, we have got this we call as a one hot encoding. Okay. What happens is in the machine learning, when we are getting into this world of programming, right? The the algorithms work only with the numbers. They don't work with the categorical values. Categorical values means we cannot say rainy is higher than overcast is higher than sunny, right? We cannot have an order. We can only say rainy or no rainy, overcast or no overcast, right? Or strong wind or no strong wind, right? So in that way, when we are talking about using scikit-learn type of things, we have to bring all those categorical values into numerical values, and that's where we use label encoding. What does it mean? All these are labels, whether the label is present or not. So when we are talking about overcast, we will say we will create another field called overcast underscore, sorry, outlook underscore overcast as one field, outlook underscore sunny as one field, outlook underscore um, rain as another field. And under that, the values will be 1 and 0. Are you with me? So that way, this whole feature of Outlook will divide into 3 columns. But third column is redundant. Why? If let's say overcast, rain, and sunny are the 3 columns. If overcast is 0, sunny is 0, then rain would automatically be implied, right? From the mathematics point of view, right? So that is the reason when this is getting encoded, we get two columns rather than one column, right? That's what we do in the label encoding, and we call it as a one hot encoding. Okay, so we are going to do that. So we are getting this one hot encoder, right? And we are also getting this one. So this helps me in solving the problem. So what happens is we have used the value of x, transformed it to an array. The tags have gone. It has become a plain array. And the same thing we have done for the y mod, which is yes or no. Now we are trying to do the split once again, the same code. And the Guinea thing, we have, sorry, not Guinea, we are using entropy. The variable is misleading. So we are using the, sorry, I think I've missed it. So we are talking about a y mod is done. Then we are splitting it because x mod is not defined. Let me call this function also. I need to hurry up. So then we are calling this. Why you are taking so much time? So yep. So we have got the model now, the descent tree without any error. We should see that without any error, right? The model is created. Now we are using it to predict using the X test. Now the test part of the data is going to get used, and we have got this as an outcome. Now we compare this with the test, right? The test, the actual value versus the original value with the predicted value. We get certain 0, true, 2 values, 3, false values, but we have got one sample in error, another sample in error. Remember Madhav's session, we have got this confusion matrix, right? So which basically means we have not got a very good accuracy here. Okay, so our data has got a noise, or we need more parameters, right? So our accuracy is 60%. Now we might think of adding more parameters here to improve the accuracy. We have created a classification report, which we have seen earlier, precision, recall, and F1 parameters. So I'll not go into the detail of this in the interest of time, but let's now add another column called temperature. Remember temperature we had? So we have added the temperature, which has created this value, right? So this has created a new set of columns, which added a new set of columns because of the temperature. Temperature has got values called hot, mild, cool. So it has added two more columns. Again, we have done the divide. Then we had again created a tree classifier. We had done the predict, okay, and then right. This is a repeated code, so I'm not sharing it here. Confusion matrix. So we get this again. We have more. We have earlier it was 2, now it is 3, but the accuracy overall has come down. So temperature is not helping us. It is actually creating more confusion. And classification report, right? So there is a this is the end of the programming that you will use using the scikit-learn without really going deeper into the concepts. So I've covered both the parts. Now there's one important thing that I think is important to introduce, and it will happen in the next sessions also. When we are looking at this whole space of data, right? If it would have been two features, the let's say over outlook and humidity, then uh, yeah, this is coming out to be very big pictures, but if can I this is yeah. So what would happen is this red is indicating let's say play, and blue is indicating it as not to play, right, in the original. But when we are actually doing the prediction, our model is creating a zone. In that zone, if the data sample new sample falls in that zone, it will predict as yes, right? And in the blue zone, it will predict as no. So what happens is our model typically tries to create this boundary for prediction, right? And overfitting basically helps. What does it lead to? It leads to creation of such kind of very specifically trained data points in the data sample, and what would happen in this might be a noise, and when the real data comes, it will get classified incorrectly. And the when you come to decision tree, something similar you will observe. I have not created this sample, but you can do it. The reason of not creating this kind of decision tree because I have only 1 and 0 as a possible values. Whereas in this sample, this is more clear because you have a varying value from -2 to 2, right? Decision tree is an important concept to visualize how your data looks like. But as soon as you become more than two features, it becomes difficult to imagine. Okay. This is just for ensuring that you understand this concept. And this is depiction of what we face when we have done the overfitting. Your training accuracy goes higher with more and more depth and more data, right? But more and more depth is more important, and but validation starts dropping off, right? Yep. Yeah, very less score, and I'm not gone into deeper into it. That's where you actually start running into iterations. You start playing up with, let's say I will not take up the best one as a root node, that is outlook. I will take, let's say, wind as a starting node. I might get a better accuracy. Okay. All right. Right. Now, for overfitting, what happens is if you go by the tree, you actually see all of them as rules, right? So, Anjana, you have come on the screen. That basically means an alarm for the time. How much time is
Yeah.
left?
So we're left with 7 minutes. We okay if you go a little out. I just want to be cognizant of everybody's time. If they are okay, the session will
Yep.
go on.
I would probably finish in 7 to 10 minutes. This is probably the last part. Okay, no, not last part. Continuous variables is also coming up, but this will not go into programming. Will not go into programming. Okay. So tree were actually a conjunctive rules, which basically means you have an and logic as you are traversing the tree. So if there is no rule, you are on the root. If feature is equal to sunny and humidity is equal to high, then you will play, right? Right? That's the rule that you form from the tree across all the branches. Yes, right? Now what we are going to do is we are going to use these rules and prune them. Prune them basically, I will remove one condition. For example, in this case, if I remove humidity equal to high, right, and stay with this particular rule and see what is the validation accuracy I'm getting, right? If my validation accuracy doesn't get too much compromised, that means this was a redundant and might be causing an overfitting. With me? Yeah. That is what we call as one of the ways to fit the to avoid the overfitting in our generic algorithm. Also, you can keep the depth of the tree as shallow as possible. So when you look at Anjana, I suggest if you can share I this IPyNB, because the recording and the IPyNB file together would help this greatly. So if
If
you
it's a
look at this,
collab, if it is a collab link, we can put it on the
I have the
YouTube.
collab link. I just got into little rush. I could have
Not
shared
a
it.
problem. So we'll put it under the video. We'll put it on YouTube. We'll
Yeah.
put that so that everybody can access that collab link.
I didn't use the collab. The reason was that these images were not coming there. Collab doesn't show the images. So I had to leave it. But I could have thought about that IPyNB file still would have been useful. I missed it. So this particular function is important given all the concepts we have heard, we have seen. This tells us which discriminator metric we have to use, Gini or entropy, or there is one more parameter we can use. Then maximum depth of the tree. Should we want to go to 4, 3, 2, what level we want to go? Probably I'm doing more overfitting. Let's say if we would have gone to 2, what is the leaves that we will allow? Minimum leaves. If there's only one leaf coming, we will not go further. It will stop, right? And similarly, I think there should be a possibility of maximum leaves also, right? If there are too many leaves, we will also not go further down in the tree. These are the parameters from the concepts you can apply in this formula, in this function call, and do your work, right? Okay, further down. Yeah, I was thinking if I'm on a mistake on VPN. Yeah. So this ends the rule pruning. Anybody has questions quickly on the rule pruning? Rule pruning basically converting all the tree into rules and then removing the conditions which are not hurting your validation accuracy. So you are removing those branches, right? Okay, right. This is a way to explain, but you will stay in the tree only. Okay. What happens in the continuous values? Continuous values we have seen in the beginning when we were talking about that big example of the tree. You basically decide on the threshold based on which the values will be in the positive values will be in one class or the other class, right? That is, or you may consider a group of threshold values, a group of threshold values. So for example, I am used this example. Let's say the temperature, we have 14 samples of temperature. I can divide this whole, this is a continuous variable, right? If I have to use classes, then I might end up creating 14 classes because all of them could be different, right? And that's not a very useful thing, right? So what I will do is I'll divide into, let's say, 2 or 3 classes based on certain threshold. For example, up to 18, I will say it is cool. From 18 to 25, I might call it as mild, and from 25 onwards, I would call it as a hot, right? That kind of differentiation I can create, and that can be done manually. But we have got a utility. Uh, this part you will see it in the NPyNB, IPyNB. This is the function that I have used here. I've said to it that divide this whole data into 4 bins, right? And use the encoding mechanism as a ordinal value, because temperature for me was ordinal, right? The categories should be in a order format. Otherwise, there could be in other formats like one hot encoding. So this function will return me one hot encoded values of the feature, right? After doing the categorization, right? I'm not sure my voice looks like cracking. Is okay?
Your
So far,
voice
okay.
is okay, Vineet. Just had two questions which came during the chat that when you were talking about the depth is important in the decision trees. So how to determine the proper depth
Yeah,
of a
it's an
decision?
iterative process. It's a iterative process, no formula. Generally in machine learning, you have the algorithm, then you have to go on the heuristics, right? And then you have to iterate. Basically, what we call it as a solution space, and you have to hunt for a better solution. There can be some formulas and the domain knowledge, and the domain knowledge also helps, right? At every juncture, when we are talking about wind, how many parameters? For example, in this temperature, unless until I have an experience about the temperature, I cannot really do the binning, right? The similar thing happens for the depth also. So the domain knowledge is another thing that helps person to limit it, right? So when we talk about machine learning, domain knowledge is very, very important. It's just not mathematics only. Okay. Now coming to that, so what we have done is we are told this, it has kind of created a model, which we call it as a EST. Then we fit the whole temperature into that model, and then we have used it to transform that general thing into the final data, which is appearing now. Instead of those values, it is looking like 31001, right? That's how the continuous variables are dealt with. The function is written in the IPyNB file. Other strategies, I talked about one hot encoding, but then there is a not one hot encoding, but there are many strategies which are there for the binning. One is a uniform that we have seen. Another is a quantile. Quantile means I'm not going to look at, sorry, I'm going to look at that every bin has got equal number of people, right? It basically divides the number of people into the same number of data points. Then K means is look at the n number of data points which are in your neighborhood, and then use the mean value of that in your data set, or maybe the maximum occurring values in your data set. So there are various strategies for the transform for the binning. Okay. So the, and also the similar thing, we use similar thing, not exactly that thing, but they are missing values in the data. So we use various strategies to fill the values of the missing values in the feature columns. If there are too many feature values are missing in a particular data sample, we drop that. This we have seen in the data engineering in the previous sessions, no different. And that's the end of it. Very important to share here, and the credits are mostly to this textbook. You probably can find it easily on net, as well as this is a very old book and very conceptual book. If you want to go deeper into these concepts, you can use it. Okay, rest of the URLs, you would find more content than what I have shared. If you have a interest, you can go deeply. All these examples are used in this notebook. Thank you so much. I'm done. Sorry for overshooting the time.
Some couple of questions which came now. Somebody want code for SMOT, SMOT.
Yeah, Praveen probably can answer it. I'm not
Yeah.
across this. This acronym is not heard before, or may I have heard but I've forgotten. Sir, can you share these books? No, I cannot. IPRs.
So why don't you just take a note of this name and then Google it? I think you should be able to find whatever, references, if it is available freely or not.
Yep. Dataset for carrying out the design tree. Yeah. Dataset is very popular. You'll find on the internet. I intentionally use something very popular because you will get multiple references besides this lecture. You should be able to learn this. This is very foundational for the machine learning. You will learn more complicated thing. I suggest before you land into the next session, you should have seen this session before. Okay. Uh, this is going to be important session for the next one. Random forest and other things are going to build on this.
Thank you so much, Vineet. Thank you for, taking such a deep dive into decision trees. So now it's up to the people to make a decision on what they want to learn. So there are a lot of people who were saying share the recording. For your information, this session is always, uploaded on YouTube. We do it after the file is ready, and maybe it takes a little while, but then it will be done before certainly the next session. So take a load of the session before you come to the next session on random forest, which is certainly going to be covering all the concepts we have covered till to date. So thank you, Praveen, also for answering so many questions over there, and Madhav being there, and Vineet and Aishwarya. Thank you for the
There were
session.
actually more people there, I think, from our
Okay. You guys were
which
attending and
are
asking questions.
yeah, no, not asking, but they're actually answering. And thanks to all of the audience who were helping and moving the session and engagement. I think virtually this was my first session. It becomes very difficult to stay engaged unless until there is an interaction. I consciously made a call that I'm going to look at the question answer. Otherwise, it can be very difficult.
Certainly,
Yeah,
certainly. Remote sessions are, you really don't know what the audience is even able to understand or not. So it's
yeah,
difficult.
yeah.
Thank you
Thanks
so much,
all.
Vineet. Thank you.
Thanks for your participation and helping. Thank you so much. Thanks for the opportunity as well. Thank you. Bye.
Bye. Bye.
Thank you. Thank you,
Okay.
everyone.
Thanks.